So using the Burnside lemma, first of all, we need to list the invariants of each element in the group. Each element here corresponds to a permutation. So a permutation is either a reflection or a flip. And the identity, and now I have n colors, remember, so identity does not change the configuration. So all of the n to the power 3 configurations, they are all invariants under this this element, right? Because when you have a configuration, whatever that is, apply E, which does nothing, you will have the same element. So all n to the power 3 configurations are invariants under E. How about R, a single rotation? Now a single rotation, now consider the scenario. This was the rotation in this way. So after I apply rotation, this here is going to go to this here, okay? Which means for this element to be an invariant, the color of this and this should be the same, so that when I rotate this, it doesn't change. But then this one also goes to here. Okay, so the color of this and this must also be the same. So if an element is an invariant with respect to R, okay, then all three vertices must have the same color. Since I have n colors, there are n such configurations. Color 1, color 1, color 1, or color 2, color 2, color 2, or color 3, color 3, color 3, etc. Okay? The same logic applies for R squared too, because in this case, it's not like this, but like this. But the logic is the same. So these two must have the same color, and these two must have the same color. So all of them must have the same color, which gives me a total of n invariants. And let's look at the flips. If I flip across this and this will be swapped. So after the flip, if I want the configuration to stay the same, they should have the same colors. But this one, it stays put. Wherever it was, it's going to be still at that position. So these two must have the same color, but this one is independent of that. So I can choose another color for this. Therefore, I have actually two selections here. These two must have the same color. So select one color among n for those. And this one is independent of those. So the number of invariants for each of these flips is n squared. Okay, therefore, applying Burnside's lemma, remember what it was. The total number of orbits, which means the total number of configurations in this case, is the average number of invariants, average number of fixed elements. Okay, so here for this element I have n to the power 3. For this I have n and n for these two, and for the flips I have n squares. Therefore, add them all up, n cubed plus n plus n plus n squared plus n squared plus n squared, divide by the number of elements in the group, which is 6, the number of permutations, and that's your answer. N cubed plus 3n squared plus 2n divided by 6. Now, the number of invariants are also evident from the structure of the cycles. When you look at E, you have 3 cycles. Okay, so 1 goes to 1, 2 goes to itself, 3 goes to itself. So those are the ones that should keep their colors. So I have just 3 independent choices here. So that gives me n to power 3. And this one, on the other hand, 1 goes to 3, 3 goes to 2, 2 goes to 1. So when you apply this permutation, for it to be an invariant, 1 and 3 must have the same color, and 3 and 2 must have the same color, and 2 and 1 must have the same color. So there is only a choice of n here. Same goes for this one. And these three, you see, I have a cycle of 1 and another cycle of 2. So I have one selection n choices for this one and n choices for the second cycle. So that gives me n squared with the flips. And therefore, the total number of colorings is this expression. And in fact, we can all see this verified in the colorings as we have seen earlier. When n equals 1, this gives you just one combination, one configuration. If n equals 2, that means you have 2 colors. So you have 4 different colorings. And finally, n equals 3, you have 10 different colorings. But this is the general formula. If you have like 10 colors, for instance, that's 10 to power 3 plus 3 times 10 to power 2 plus 2 times 10 divided by 6. That's the number of colorings you can apply when rotations and flips do not change the outcome.